Welcome to our extensive tutorial on using networking for multiplayer games in Java. In this series, we will dive deep into the concepts and provide practical code examples to help you understand how to implement these ideas in your games. To start off, let's understand the basics of networking in games. Multiplayer games generally require communication between different clients and a server. The server manages game state, while clients represent players. We will utilize Java sockets for this communication. First, let's set up our project environment. You can use any IDE you prefer, but IntelliJ IDEA or Eclipse are two popular choices. Make sure you have the Java Development Kit, JDK, installed. Create a new project titled Multiplayer Game Networking. Within this project, we will create a package named Network. This will contain our server and client classes. Let's start coding the server class. This server will listen for incoming connections from clients and handle the messages they send. In the code above, we set up a simple server that listens for client connections on port 12345 using server socket. Each client is handled in a separate thread by the client handler class. Next, let's implement the client class. This will connect to our server and send messages to it. In the game client code, we connect to the server and allow users to send messages from the console. A separate thread listens to incoming messages from the server and displays them to the user. Now, let's test our server and client. First, run the game server class, and then start multiple instances of the game client class. You can type messages in each client, and you should see them reflected in all other clients connected to the server. This messaging system forms the core of our multiplayer game networking. However, it's essential to handle disconnections cleanly. Let's add some error handling in our server's client handler class. In the run method, we handle the IO exception when a client disconnects, allowing us to perform necessary cleanup, like updating the client list. Let's talk about game state synchronization. In multiplayer games, it's crucial that all clients have a consistent view of the game state. This could include player positions, scores, and game events. To illustrate game state synchronization, let's extend our server to manage a simple game state. We will define a game state class and modify our game server to keep track of it. In the game state class, we maintain a map of player IDs and their positions. We ensure thread safety with synchronized methods to avoid inconsistent states when multiple threads access the data concurrently. Now, integrate this game state into our game server. When a client sends a position update, we will update the game state and notify all other clients. Here, we fetch the player's ID based on their IP address and update their position in the game state. We also broadcast the updated game state to all connected clients, ensuring that they are up to date. Next, let's update our game client to handle the game state updates from the server. We will parse the game state message and display the player positions. In this updated listener thread, we check if the incoming message starts with game state. If it does, we treat it as an update of the game state and print it. Now, if you run your server and clients again and send position messages like Player 1, Position 50,100, all clients should receive game state updates reflecting the positions of the players. Next, let's discuss the concept of reliability in networking. With UDP, you can send messages without a guaranteed delivery mechanism, making it suitable for real-time applications. However, for most multiplayer games, a reliable communication protocol, such as TCP, is preferred, especially for game state updates. Beyond reliability, latency plays a significant role in multiplayer games. Techniques like client-side prediction and lag compensation can help improve the user experience. As we're using TCP for our prototype, let's talk about security practices. Implementing proper security measures is crucial to protect your server from common attacks such as DOS or packet sniffing. Always validate input from clients and consider using SSL for encrypted communication. To implement SSL in your Java server, you need to set up an SSL server socket factory. Here's a brief overview of how to do it. In the above code snippet, we use SSL server socket factory to create an SSL secured server socket. Remember to configure your key store and trust store properly for SSL connections. Now that we have a rough structure ready for our multiplayer game with networking, consider what kind of game you want to build. You can expand on what we've learned by adding features like player authentication, different game modes, or even integrating databases for persistent game state. In summary, we've set up a basic networking structure for a multiplayer game using Java sockets. We explored the server-client model, implemented message passing, synchronized game state, discussed security concerns, and reviewed enhancements like SSL. I encourage you to experiment with the code, modify it, and enhance your multiplayer game as you see fit. Don't forget to subscribe for more tutorials on game development and programming in Java.